And we have a special guest with us here in Mission Control Houston today, two-time long-duration space flyer Peggy Whitson, as mentioned, an accomplished biochemist in her own right with a degree from Rice University in biochemistry. Peggy, welcome.
It's great to be here today.
We're glad to have you on Space Station Live, and the reason we're talking with you today is we're talking about microencapsulation. And I'm going to let you explain it, but the reason we're talking about microencapsulation is because we did a countdown of the 10 top research results and experiments on the International Space Stations. We're getting ready to recognize the 15-year anniversary of the first Element launch. You were one of the early space station crew members on Expedition 5, and you worked with the microencapsulation experiment on orbit. Tell us a little bit about it.
Well, actually, the microencapsulation experiment on orbit was actually, from a crew member perspective, relatively simple. We just put in these canisters and activated them, and what we were doing is building these little, basically, bubbles that can be used in technology as either delivering drugs and various different techniques for application here on the Earth. But we were just trying to build the bubbles and understand what makes them, how to make them the best way and the most effectively. And so we were using the lack of gravity as our tool to see what other variables can influence how these little capsules can be made here on Earth, which is great for us because up on orbit we can test these things out and find out all the nuances of the different things that influence making these capsules. And what's really, I know it's been since Expedition 5, and that seems like a long time ago, but that's actually kind of how research runs, especially research that involves human beings. It's taken this many years to get these capsules to the point where we're going to actually try and test them here on Earth to carry, in some cases, they're going to carry markers that can be used then to by the doctors to visualize where the cancers might be located, so the capsules will go and know how to attack and attach to a particular type of cancer. And then the doctors can visualize that cancer better because the bubbles inside will have little fluorescent or marker beads that can actually be visualized, and the doctors can attack it directly by using ultrasound to visualize it and inject things. It's also planned for future uses where you would actually put drugs inside those little bubbles, and they would then attack the cancers directly. So it's really exciting that we're getting to that phase where we're taking something that we tested out on orbit, found out how to optimize making these little capsules on the ground by taking out gravity as a variable, and now we can test something in human beings that hopefully will have a future for us in helping to cure cancers, or not so much cure cancers, but to help us fight more effectively cancers as they grow in our bodies.
Well, and that could also, as I understand the way they're hoping to use this in drug delivery, help make cancer treatments a lot less hard to deal with for the patient. Right now, you pretty much pollute the entire body with the anti-cancer chemicals. This allows you to pollute just the area that you really want to target.
Yes, that's a very good point. So it'll be very much a targeted drug delivery mechanism. So it's very exciting. But human research does take years, especially from the concept, the idea, and then to get it to where we're actually testing it in human beings. It does take years, and that's standard here on the ground. When we're doing research, it takes that long. But it's very exciting that something that began on the International Space Station has come this far.
Well, so tell us, as a biochemist, are there any other experiments that are particularly interesting in your view that have come out of space station research?
Oh, well. I have lots of favorites that I've worked on over the years, doing different research. But the ones that are most appealing to me are the ones where the crew member gets to interact the most. We do a lot of crystallization, but mostly that's activating and starting an experiment, and zero gravity is the variable that causes these things to happen independent of the crew member. So from a crew member perspective, the ones that are most interesting are the ones where we get to actually be involved and be a part of the experiment. One of the more interesting ones for me, again, that illustrates why we do research in an environment like the space station was an in-space experiment where we were looking at this um, colloidal suspension of iron particles in a magnetic field. And one day I turned the magnetic field, or the magnetic electromagnetic field, and set it at the wrong setting because my eyes were getting a little old and I missed the decimal point. Instead of 20 hertz, it was 2, 2.0. And we saw a very different response to what they'd seen on the ground. And so once we finished up the experiments at 20 hertz, we went back and repeated them at 2 hertz. So the investigators would have this whole new data set that we just by accident found on orbit. And a lot of times, research in the laboratory here on the ground, the most interesting research is, I wonder why that happened. And you go and try and figure out, why did that happen?
Well, serendipity was always my best friend when I was doing any kind of a research for my college degree. Yeah, and Mike Hopkins was working with the in-space experiment yesterday. He had some extra time, and he was able to pull that together and do some work in the microgravity glove box. So it's obviously still a favorite up there because you can see things happening.
Right, yeah, and it's a lot of fun because the crew members are very involved. And they have to set up things, and you get to watch what's happening at the time. And so, from a crew member perspective, those are the fun ones to do. Enjoyed doing the ultrasound. We were developing ultrasound technology and distance telemedicine techniques to utilize this technology for remote medicine on board the space station, but obviously that could apply here on Earth in remote rural locations where you might not have an expert ultrasound technologist, but you could do some remote guidance from somewhere else and have the experts look at the data and tell you, what might be the problem. So all of this is great application for us going on beyond, low Earth orbit and doing exploration in the future, but it's really neat that it actually does apply here on the ground as well.
Definitely, we're looking at the benefits for humanity from the International Space Station. I want to thank you, Peggy Whitson, for coming to visit with us today. We appreciate you great taking time out of your day and to share your expertise with research and your experience on board the International Space Station. Peggy
No problem.
Whitson,
No
thank you.
problem. It's a lot of fun. Glad to share.
Thanks.